Hello, my dear students. Hope you are fine. So today, once again, I'm back with one more video to share with another important chapter that we were discussing regarding the atoms and molecules. So in my previous videos that I had uploaded, I was discussing regarding the discovery of atoms as how the names came out. All right, the atom. The Indian as well as the Greek philosophers, how they were involved in the findings of this smallest particle called as atom. Simultaneously, we found that it was a long time back that the treasure or the hunt in order to get the smallest particle of a matter was really wondered about. And in later course of time, long time after that era, around by the end of 18th century, we found that practically the works pertaining to the discovery of atoms started with valid proofs regarding the discovery of atom. And accordingly, we found out there were two scientists involved in it. They were Antoine L. Lavoisier and Joseph L. Proust. These two scientists actually worked on the aspects of atom that was laid as a foundation stone by the Indian and Greek philosophers, and in later course of time they came out to explain the findings of atom with the laws that they established, that were the laws of chemical combinations. And in this law of chemical combination, we found that it consisted of two laws that is law of conservation of mass, and the another was law of constant proportion. And accordingly, we saw by definitions what were this law of conservation of mass and law of constant proportion. Their laws actually elaborated the way the thinkings or not the findings, I would say, the thinkings that were being done long before by the Indian and Greek philosophers. They actually practically made it possible for us to understand as what this concept of atom lies. And with their laws, that is law of conservation of mass and law of constant proportion, we were into a limelight where we can really understand what the atoms basically were. But their laws were self-explanatory. Self-explanatory in the sense that what they said, we read it out, we understood, but we could not correlate. We could not correlate the matters with our thinkings, right? You know, human mind always treasures to find out newer and newer things. And as such, human beings goes for that. And as accordingly, the modern day scientists also try to work out on these aspects. The laws established by these two scientists, that were Antoine L. Lavoisier as well as Joseph L. Proust, these two scientists, what they explained, had a detailed explanation, or rather a detailed elaboration of the topic or laws that they explained. And as such, these laws, in order to practically imply with our understanding, it had to be made clear. And thus, in later course of time, after the two laws came into effect, one more scientist who actually worked out with the laws of chemical combination tried to explain the laws of chemical combination in his own way, so that it becomes much more clearer for all of us. Alright? And as such, another scientist named John Dalton, alright, John Dalton worked out with these two laws of chemical combinations, and later on came up with his ideas to explain what this atom were. And today we shall be discussing about the Dalton's atomic theory. Alright, Dalton's, what was his way of explaining the atoms. Going through both the laws, he could come to a conclusion where he explained those laws in terms of certain points. Now, if you look into the first point, what he explained from these two laws, that all matter is made up of tiny particles called atoms. So this was not only a concept that was lying with the two laws established by the two scientists Antoine Lavoisier and Joseph L. Prost, he also took the idea of the ancient Indian and Greek philosophers who actually wanted to express their views, but they didn't had any experimental verification to the subject matter. Now, Dalton made it very clear with his first point that all matter is made up of tiny particles called atoms. That means whatever we have with us, any form of matter, table, chairs, mobiles, beds, any damn things that you have around you, all are made up of atoms. That means the tiniest particle, what we discussed regarding Maharshi Kanat's way of telling the fact regarding the atom, that if we go on dividing a matter, ultimately a time will come when we will obtain the smallest particle of a matter, and this smallest particle of a matter he named as atom or Parmanu, what we say. And thus accordingly, John Dalton is also of the view that all matter is made up of tiny particles called atoms. Alright? Coming to the next point that we find here is that atoms are indivisible particles. Alright? Atoms are indivisible particles that cannot be created nor it can be destroyed in a chemical reaction. Now, if you look into this point that he mentioned that atoms are indivisible particles that cannot be created or destroyed in a chemical reaction, here you come to know, or you can compare the law of conservation of mass. What did this law of conservation of mass told us? That mass can neither be created nor it can be destroyed in a chemical reaction. That means the sum total of the mass present within the reactant is always equal to the sum total of mass in the product. Therefore, reactant and the product has to be equal, and that's what he tried to explain with his points, that atoms are indivisible. You cannot go on dividing up to here. Now, what it is being told, it is told by John Dalton that atoms are indivisible. Alright, this term indivisible is not told by me. Remember, this term is not told by me, it is told by John Dalton that atoms are indivisible, that they cannot be divided any further. This is the term that he mentioned, John Dalton mentioned it, alright? That atoms are indivisible particles that which cannot be divided any further, that cannot be created. Atoms are indivisible particles that cannot be created or be destroyed in a, alright, or be destroyed in a chemical reaction. That means in a chemical reaction, this cannot be neither created nor it can be destroyed in a chemical reaction. Alright? So this is what we find, that atoms are indivisible particles that cannot be created or be destroyed in a chemical reaction. Coming to the third point, in an atom the mass remains constant. This is also somewhat related to the law of conservation of mass, that as we have mentioned in our earlier point that atoms can neither be created nor it can be destroyed in a chemical reaction, therefore the mass will always remain constant. Mass is not going to change. Within a chemical reaction, the mass is never going to change. It will always remain that constant. Alright, so that the third point easily dictates us that in an atom the mass remains constant. Alright. Coming to the fourth point, that is atoms of different element have different masses. Yes, in a particular element there is atom, and therefore within an element there will be same type of atoms. Alright, you need to note it very clearly. I am repeating once again that in an element there is atom, and what the atoms present are of same types. They are not of different types. So in an element, the atoms that are present are of same type. All atoms will have same type of atom. All the atoms that are present will be of same. And as such, the mass will remain fixed. Alright, mass is not going to change within that particular element. So mass is constant from the earlier point we got it, and therefore the mass is what it is. See the atoms coming to this point. Let me tell you that within that particular element, the mass will also remain constant. Now, this mass, whatever be the mass of a particular element, will not be the same in the other element. Say for example, what is the mass of hydrogen is not same as that in oxygen. The mass of the oxygen is different. Mass of hydrogen is different. Alright? Why? It is because the atoms present in hydrogen is different as compared to the atoms present in oxygen. Therefore, whatever mass is being possessed by the atoms of hydrogen will not be the same in case of the mass beared by the atoms present in oxygen. Alright, that is the reason why this statement clearly tells us that atoms of different elements have different mass. Okay, now coming to the fifth point. Alright, fifth point, what do we find? That atoms combine in the ratio of small whole numbers. Now this point, if we look into from the point of view of Dalton, that what he has mentioned, that atoms combine in the ratio of small whole numbers. Now if you go through the law of constant proportion, from that law it is very much evident that whenever the elements are combining, alright, the elements are combining, atoms combine in the ratio of small whole numbers. So ultimately what you get, if you want to find out the ratio present within a particular compound, the ratio will be combined in the smallest whole numbers. We have already discussed regarding the fact that they combine in the ratio of small whole numbers, right? From the law of constant proportion, we have already discussed that they combine in the ratio of small whole numbers. So from that, this law has become very much clear to us that atoms will always combine in the ratio of small whole numbers in order to form what you know, in order to form compounds. Okay, in order to form compounds. Coming to the sixth point, if you go through your book, alright, if you go through your book, what you will find that the sixth point as mentioned, alright, the sixth point as mentioned here is that the relative number and kinds of atoms are constant in a given compound. So in order to understand this one, what we need to understand, what actually Dalton is trying to explain, that in a compound, the total number of atoms remains constant. Now the total number of atoms, what I am talking, earlier we have told that the mass remains constant. Not only that, but also the total number of atoms remains constant both in reactant as well as product. Alright, both in reactant as well as product. This has to be understood, that not only the mass but also the atomic number, or rather the number of atoms remain constant. Alright, so ultimately we can draw from Dalton's atomic theory is that number one, atoms are the tiniest particle present within the matter. Alright, and next is they are indivisible particle. The most important point that we need to understand is that they are the most indivisible particles that cannot be created nor it can be destroyed. That means from the law of conservation of mass, this point was clear that mass can neither be created nor it can be destroyed, and accordingly atoms are the indivisible particle that cannot be created nor it can be destroyed. Third one, that the mass remain constant. Alright, the mass always remain constant. Next one, the mass of a particular element is different as compared to the mass of other element that we have already discussed. And the fifth point that we have already discussed now, that atoms combine in the ratio of a small whole numbers. And lastly, that in a compound the total number of atoms always remain constant. So go through this video, all right, and follow my next video. So till then, thank you.